Hello, I'm Paul Beckwith. In the last two videos, I was talking about abrupt climate change in the past, present, and future. So this video is a continuation of this, and I'll talk specifically about sea level rise and its history. Sea level rise is of great concern for many people around the world. It's a major issue also for climate restoration. To deal with it, we need to consider how sea levels have changed dramatically in the past. During the past 2.588 million years of the Quaternary, which was formerly known as the Ice Ages, there's been an ice cap on both poles. Ice has extended from the poles in many periods of glaciation, with interglacial periods between them after the ice is retreated. The sea level has reflected the quantity of ice, which varied with global temperature at most 2 degrees Celsius above the present and about 6 degrees Celsius below. During the last interglacial period, known as the Eemian, beginning about 130,000 years ago, sea levels were similar to those of today, but temperatures were about 2 degrees Celsius warmer. At the end of the Eemian, there was a sea level rise of 6 to 9 meters, of which perhaps 4 to 6 meters came from Antarctica, probably the West Antarctic Ice Sheet, the WAIS, and about 2 to 3 meters from the Arctic, probably the Greenland Ice Sheet, GIS. Although, other work seems to indicate that it's about 50-50 spread between the two, initially with most of the rise coming from Greenland, and then subsequent to that, the bulk of the rise taking over from Antarctica. So after the Eemian, glaciation set in, and the sea level fell until the last glacial maximum, which peaked at about 21,000 years ago, when global average temperatures were about 6 degrees Celsius colder than today, and the sea level was thus 125 meters lower than today. Subsequent to that, the sea level has risen at varying rates with these so-called meltwater pulses. So it hasn't been at a uniform rate over time. During these meltwater pulses, the rate of rise was sometimes about 5 centimeters per year, or 2 inches per year. 5 centimeters per year, of course, in a century, 100 years would be 500 centimeters or 5 meters. So this is what the system is capable of, the rates of sea level rise that the system is capable of happening, because it certainly happened in the past. For example, in meltwater pulse 1A, before the Younger Dryas cold spell, the seas rose about 20 meters in 400 years, something like that. The Holocene period followed the Younger Dryas. Temperature and sea level rose to a peak during the thermal optimum and then steadied. The constancy of climate allowed agriculture to be developed and settlements to grow in size. Over the past 2,500 years, the global temperature and sea levels have been particularly constant. Global temperature and sea level rise only began to change significantly in the 20th century due to global warming from greenhouse gas emissions. About 2/3 of that warming from CO2 and about 1/3 of that warming from methane. The emission of SO2 when fossil fuels are burnt has a cooling effect, particularly through a brightening effect on clouds. This cooling, also known as global dimming, has offset the global warming by as much as a half. The net warming effect was sufficient to raise global surface temperature by about 1 degree Celsius and sea level by about 20 centimeters or 8 inches over the century, mostly due to thermal expansion of the oceans. So you heat up the water, we'll see at the surface it expands, it overflows the basin, and we see it as sea level rise. Now, of course, ice sheet collapse is entering the equation in sea level rise, ice sheets from Greenland and Antarctica. It's worth mentioning that the huge collapse of ice sheets in the past, as a warning to the future, to now and to the near future. We know that up to a third of Greenland ice was lost at the end of the Eemian, contributing to 2 to 4 meters of sea level rise. It could have happened with avalanches of huge blocks of ice descending into the sea at great speed. The blocks could have been a kilometer or more in thickness and several square kilometers in area, so just massive, enormous blocks. There are signs of scouring on the seabed at a depth of 800 meters off the west coast of Greenland. And we think that this may have been due to calving, to these huge blocks breaking off of Greenland, entering the ocean off the west coast. The tsunami waves generated from these blocks of ice would have been kilometers in height in the local region, and they would have spread across the oceans, not with that height, with the height reduced somewhat from that. And lending credence to this possibility is the evidence of tsunami action in the Bahamas that is dated to about that time. About half the power of the tsunami waves leaving the west coast of Greenland for the Atlantic would have been reflected towards the Bahamas by the underwater mid-Atlantic ridge, which runs due north-south for hundreds of kilometers. Such tsunamis could have flung 1,000-ton boulders from the seabed up a 20-meter high cliff on the island of Eleuthera, although Jim Hansen thinks that waves from superstorms did it. Okay, so I did a whole series of videos on these studies from James Hansen. Although Hansen claims, the island of Eleuthera, Eleuthera, the coast faces to the northeast, straight towards the underwater ridge, the mid-Atlantic ridge. Although Hansen claims the boulders were moved by waves from superstorms, there is little evidence that storm waves could be large enough to hurl a boulder of such weight 20 meters from the sea, although maybe it was trains of these massive waves. Hansen points out that the distribution of boulders suggests a number of waves, but then there would have been a large number of tsunamis generated by partial collapse of the Greenland ice sheet. After the Eemian came a glacial period, with the last glacial maximum occurring about 21,000 years ago, the peak of it. Subsequently, some of the great ice sheets that had built up started to disintegrate with surges of meltwater in several pulses. About 8,000 years ago, in the early Holocene, the great ice dome over what became the Hudson's Bay collapsed. There are signs of seabed scouring from this collapse. Again, huge tsunamis would have been generated entering the northwest Atlantic. Again, there is evidence on the island of Eleuthera with boulders at a lower level on the beach dated to the early Holocene, to this time period.